Alright, so let's do a quick review of how exponents work. In this example, 2 to the second power raised to the third power, we know that 2 to the second power raised to the third power means there's 3 of these things. So it's 2 to the second power, but I need 3 of them. Well, 2 to the second power is 4, 4, and 4 leaves us with 16 times 4, which is 64. Okay? We also talked about maybe what you would call a shortcut. Shortcut says if there's an exponent raised to another exponent, or a power raised to a power, you grab them and you multiply. Keep the base, which is 2. Multiply the exponents, which is 6. 2 to the sixth power means 2 times 2 times 2. 6 2's. And then I like to do grouping. I know that 3 2's is 8. So here's another 8. And 8 times 8 is 64. So we get the same answer either way. Doesn't matter which way you do it. We've talked about how when there's variables like a, if it was a to the second power raised to the third power, it's very quick to just then grab your exponents, multiply them. Keep the base, multiply the exponents, and you're done. That would be your answer there. Again, that works anytime there's an exponent raised to another exponent. You keep the base and you multiply the exponents. So, our rule for raising a product to a power, in this example here, 5 times 3 raised to the fourth power. Well, I know that means 5 times 3 raised to the fourth power means I have 5 times 3, but I have 4 of them. 5 times 3, another 5 times 3, another 5 times 3. Okay? But I could think of it this way. The 5 has a 1 exponent, the 3 has a 1 exponent. So really I could grab my exponents, grab the 1 on the inside and multiply it by the 1 on the outside. That's the same as 5 to the fourth times 3 to the fourth. We would get the same answer either way, because if you look down here, 5 to the fourth power, there's 4 5's which will all be multiplied. Well, that's the same as 5 to the fourth. There's the number 3 4 times, 3 to the fourth power. We'd get the same answer either way. So the rule for raising a product to a power says to raise a product to a power, raise each factor to that power. So whatever the exponent is on the outside, you're going to multiply it by the exponent on the inside. And if you don't see the exponent, remember the invisible 1 is there. So let's practice a little bit. Why don't you take a couple minutes, try these, pause the video, stop back and see me when you are ready. So in letter A, 2 ways to think of it. Kind of the maybe slower way is to say, well, I have 2 times 3. And it says I need 3 of them up here. So I got to write this 3 times. Well, to do the work now, 2 times 3 is 6. Here's another 6. Here's another 6. 36 times 6 is 216. Got it. Or maybe a little faster is to say, oh, the exponent on this 2 is a 1. The exponent on this 3 is a 1. I'm going to multiply the inside exponents by the outside. 2 to the third times 3 to the third. 2 to the third is 8. 3 to the third is 27. And 8 times 27 is 216. Same answer either way, however you like to think of it. In letter B, I'm going to do this the shortcut way right away. This 2 has an exponent of 1. The letter P has an exponent of 1. I'm going to multiply the inside exponents by the outside. Keep the base of 2. 1 times 4 is 4. Keep the base of P. Multiply the exponents, get 4. 2 to the fourth power, I know is 16. So I get 16p to the fourth power. Again, I'm going to do the shortcut here on letter C. X has an exponent of 1. Y already has an exponent of 2. Inside exponents times outside exponents. Keep the base x, multiply 1 times 5 and get 5. Keep the base y. 2 times 5 is 10. X to the fifth, y to the 10th. Same thing in letter D. The 5 has an exponent of 1. X already has an exponent of 3. Inside exponent times x outside exponent. So now I have 5 to the second power, x to the sixth power. 5 squared, or 5 to the second power, is 25. So I've got my answer here, 25x to the sixth. In this next group, they threw some negatives at us. And we've talked about the strategies with negatives. In letter A, this negative is in parentheses. It's glued onto the 2. Think of what that means. I have negative 2 and a y. And it says to the fourth power, that means I need 4 of them if I'm going to write all this out. But the negative is glued onto the 2 every time. Now in letter B, the negative sign is outside the parentheses. Our strategy this year has been pretend it's not there, cover it up, do all the work, and then when you're done, you say, oh, I need the opposite of that. So pause the video, take a few minutes, try all three, stop back and see me. All right, hopefully you've taken some time to try these. Let's see, the negative 2. I see 4 negatives 2, so if I think of it, it's negative 2, negative 2, negative 2, and another negative 2. Well, I know 2 negative 2's turn into 4, so I have 4 times 4, 16, and then there are 4 y's, 16y to the 4th. 16y to the 4th power would be my answer. Now I could also think of it this way. Exponent of 1 on each of these. I'm going to multiply, so I have negative 2. Remember, the negative is glued onto the 2. 4 of them. And then the y, 4 of them. Well, negative 2, 4 of those turns into 16, and y to the 4th. Same answer, different ways to think of it. Letter B, pretend there's no negative, do all the work first. Well, multiplying my exponents, I have the base of 2, exponent 4, base of y, exponent 4. This turns into 16, y to the 4th. But then I can't forget there was a negative outside which says I need the opposite of that answer. So the opposite of 16y to the 4th is negative 16y to the 4th power. The last one, the negative is glued onto the 5. So think of that. There's a negative 5, and I have 3 negative 5's. So I have 3 negative 5's, negative 5 times negative 5 times negative 5. These two turn into positive 25 times negative 5. I get negative 125. Now, I've got an exponent of 1 on the B, exponent of 2 on A. I'm going to multiply inside exponents by outside. So I get A to the 6th, B to the 3rd. That's my final answer. When we move on to quotients, which are just fractions, quotient means divide, fraction always means take the numerator divided by the denominator. So when we move on to fractions or quotients, the rules stay the same. You could think of this one, 2/3 to the 4th power. The slow way is 2/3, 2/3, 2/3, and another 2/3. And multiply across the top. 2 times 2 is 4, and another 4, 16. 3 times 3 is 9, and another 9, 81. Or I could think of it this way. The 2 has an invisible 1, the 3 has an invisible 1. Multiply the exponent on the inside with the exponent on the outside. I get 2 to the 4th over 3 to the 4th. I still get 16/81. So the rule for raising a quotient to a power is just to raise a quotient to a power, you're going to raise both the numerator and the denominator to that power. You're going to do the same thing we did before. It's just that now there's a numerator and a denominator. All right. So if we look at this group, think about the steps we talked about. You could do this the slow way or maybe the fast way. Try all 4, including the word problem, and then stop back and see me in a few minutes. All right, so I'm going to do the shortcut way. 1/2 to the 3rd power. There's an invisible 1 exponent on each of these. So that means I'm going to multiply the inside exponent and the outside exponent. I now have 1 to the 3rd over 2 to the 3rd. 1 to the 3rd power is 1. 2 to the 3rd power means 2 times 2 times 2, which is 8. Done. 1/8 is my answer. In letter B, the negative is in parentheses. It's glued onto the 2/3. So I could think of it this way. Negative 2/3, but I would need 4 of them because the exponent is 4. Negative 2/3, 4 of them. Well, I know right now that 2 negatives here would be a positive, and 2 negatives here would be a positive, and a positive times a positive will stay positive. So if I think of this, negative 2 times negative 2, I get 4. 3 times 3 is 9. I got another 4/9 here. When I multiply, I get 16/81. And the shortcut way would say throw the invisible 1 exponent on there. Multiply inside exponents times outside exponents. I got negative 2. All to the 4th power over 3 to the 4th power again gets me 16/81. Either way you think of it. Letter C, same strategy. I'm just going to go with the shortcut way. Invisible 1 exponent there. The x already has a 2 exponent. The 3 needs its invisible 1. I'm going to multiply inside by outside. So I've got 2 to the 3rd power times x to the 6th power all over 3 to the 3rd power, which simplifies down to 8. X to the 6th over 27. And that takes us to our word problem. Remember, anytime you have a word problem, slow down, read it out, think about the pieces. First thing they tell me, it's a square garden, so drawing a square would be very helpful. Now, most times on a square we say, oh, it's 8 feet on a side or 2 inches on a side. Well, they gave us a crazy measurement. They said it's 3 over m squared. And since it's a square, we know every side is 3 over m squared. Okay, they want us to find the area. Well, there's a couple ways I can think of area. Area of a rectangle, and a square is a rectangle, is when you take the base times the height. So I'm going to do that first. 3 over m squared times 3 over m squared, and I get 9 over m to the 4th. They also give us this clue. A square has this formula for area. To find the area, take one side, which is 3 over m to the 2nd power, and square it. That means 2 of those. Well, if I do the shortcut way, this 3 has an exponent of 1 on it. This m already has an exponent of 2. So the area is 3 to the 2nd power over m to the 4th power, which simplifies down to 9 over m to the 4th power, which is the same answer we got here. Doesn't matter which way we do it, we got the same answer. And the last one, same garden. So, I'm going to draw that same square. 3 over m to the 2nd power on every side. A square is the same on every side. Okay, this time they want us to find the perimeter. One way to find perimeter is to add up all the sides. So we'll do that. And if we think back to our rules for adding fractions, we must have a common denominator. And we do have a common denominator, so we keep it. And then we just add the numerators. 3 plus 3 plus 3 plus 3 is 12. Now another way we could think of it, they give us a clue. They said the formula for perimeter of a square is 4 times one side. Well, 4 times, since it's a square, I can pick any side. I've got 3 over m squared. And if I want to multiply that by 4, I'm going to turn 4 into a fraction, 4 over 1. Time to multiply. 4 times 3 is 12. 1 times m squared is m squared. Look at that. Same answer. Doesn't matter which way you do it. Good luck.